afternoon, Casey. Good afternoon, everybody.
So shall we start the session now?
Yeah, make it.
Yeah. So very good morning, good afternoon, good evening, all the members of BRSI-IBA and other members who are joined in this BRSI Global Lecture Series 17. So the Global Lecture Series have been started BRSI a couple of years back. So this BRSI Global Lecture Series I have been telling that we have started a couple of years back, and then later the IBA is also joined in the session. I request all the members to please mute yourself. So before beginning, just I request Professor Tej P. Singh, the former president and distinguished fellow of BRSA, for a few remarks.
Okay. Thank you, Vinod, and great pleasure to have this lecture by Professor Dr. Sally, well-known earth scientist. And I think it's very important to talk about blue ocean, blue economy. Very nice topic. There on the screen, but Nike is not visible. No, Dr. Naik, you are there?
I'm there.
Yes.
Yeah.
Yes.
Okay, you are there. So
Yes,
we
yes.
want to welcome you. Thank you very much. Current president of BRSI is, this is a very old time, 3:30 a.m. in US.
Very.
Some sound is coming from the background.
Yeah, I'm muting everyone. Yes, now it's okay, I think.
Okay.
Yes.
I think I switch off my camera also so that it's cleaner. So our founding president, Dr. Ashok Pandey, is not well right now. He's in USA. And current president, Professor Sapuri, is also at the wrong place where time is very odd, 3 a.m. or 3:30 a.m. So I'm very delighted to welcome you. I've been associated with BRSI since many years. And I think this lecture series, global lecture series, has been very successful. And I'm very happy this time, IBA has also joined hands. Is this right, Vinod?
Yes.
So with this topic, most of the topics in science today are global, actually. So it's a good thing that two associations, two societies are joined. And I welcome all my colleagues from abroad and all the members from everywhere. It's a very exciting topic of blue ocean to, say, blue ocean sciences to blue economy. From say blue ocean to blue economy. Very nice topic. And I think everywhere economy is very important. And sea, the oceans are such a wealth. There's so much potential to exploit. But ocean is also earth science, or earth science and ocean are different. So very nice. Anyway, Dr. Shelley, welcome. And we are very happy that you accepted to be part of this. And it's a great pleasure for us to have you here. you can have the next thing.
Thank you, sir. Now we request Professor Jose Texera, the Vice President of IBA, for remarks.
I'm here. Yeah. So good morning, everyone. I think it's my first time here in these conferences. It's very nice to see so many people attending. I think we have 34 participants, which it's a very good number. And so in name of IBA, I'd like to thank you for being here. And also I'd like to thank Dr. Shailesh Nayak for this presentation. I think, as has been said previously, it's quite an important topic, and I think we can get very nice insights in topic from this presentation. So, Dr. Shailesh, once again, thank you for being here and making this presentation. And thank you all for attending.
Thank you, Texera. Professor Sokol, are you there? Professor Sokol, President of IBA.
Hi, colleagues. Good morning, good afternoon, good night. Here is morning, 7:00 a.m. For me, it's a pleasure. I would like to thank Dr. Nayak for this talk. It's very important for us, for EBA Association. The association is for this talk, linking the potentiality of the sea, the new bioproducts from the sea is very important also for the Brazil. Brazil, we have enormous territorial sea coast, more than 6,000 square kilometers. At the moment, I come in the coordination of a new institute in Brazil that we will prospect the potentiality of the new product from the biodiversity of the Brazilian coast with more than 30 universities in Brazil. For us, this is very important, just talk about this subject. Thank you, Bino.
Thank you.
Thanks a lot. Colleagues.
Thank you, Professor Sokol. Yeah, thank you, Professor Sokol. We have Professor Christian Laroche, the Charter President and the founding member of IBA. Professor Laroche.
Okay. So, hello, everybody. For me, this webinar is a very important event, both for BRSI and IBA. And I am happy to see that quite a numerous people have joined, 33 on my computer. The topic of the presentation is also very promising, and I hope that all these promise will be attained with the water and ocean better knowledge and business which go along with it. Thank you, everybody.
Thank you, Professor Christian. So now I request Professor Archana Tiwari, the coordinator of the Global Lecture Series, to introduce the speaker and invite the speaker for the talk. Professor Archana? I think you are muted. I will unmute.
Unmute.
Yes.
Thank you.
So we are not hearing you.
Me.
Yeah, now it is clear. Yeah, fine.
Yes. So thank you so much. It's my privilege to introduce Dr. Shailesh Nayak. He's currently the Director for National Institute of Advanced Studies, Bangalore, and he's also a live trustee for Indian International Center, New Delhi, and Editor-in-Chief for the Journal of Indian Society of Remote Sensing, Dehradun. He obtained his PhD in Zoology from MS University of Baroda in 1980, and he served as the Secretary, Ministry of Earth Sciences during 2007 to 2015 and provided leadership to many programs related to earth sciences. He has set up state-of-art tsunami warning systems for Indian Ocean in 2007, which was highly valuable to the Indian ocean rim countries. And he pioneered the development of algorithms and methodologies for application of remote sensing. He's also a fellow of many societies, including Indian National Academy of Sciences, India, Allahabad, the Indian National Science Academy, New Delhi, Indian Academy of Science, Bangalore, Fellow of International Society of Photogrammetry and Remote Sensing, Academicians of International Academy of Astronautics. He is the president of International Geological Congress during 2015 to 2017. So he has been conferred very many prestigious awards, including ISC Vikram Sarabhai Memorial Award in 2012 and Bhaskara Award in 2009 for his outstanding contribution in remote sensing and GIS. He has published more than 190 papers in peer-reviewed journals. And the government of India awarded the civilian honor Padma Shri in recognition of his outstanding contributions in the field of science and technology. We are indeed privileged to have you, sir, and we welcome you for this interesting lecture. Over to you, sir.
Thank you. Thank you very much. Really very happy to participate in this BRSI-IBA Global Lecture Series. And I must thank Dr. Pandey for introducing me to this very important organizations and also giving me an opportunity to address this very distinguished people. Let me share my slides. Just 1 minute.
Your slides are visible, sir.
Yeah. I'll just make it.
Sure.
Yeah. Yeah. So thank you very much. And what I'm trying to do is some of the advances in the ocean science, how this has been utilized or being useful to address the issues related to blue economy. I think Professor Singh has raised one important issue. So before that, see, Earth as such, we consider as a single unit, and it has 5 major components: ocean, the geosphere, the biosphere, the snow and ice, and the hydrosphere. So the ocean also forms a very important part, as well as the biosphere as well. So in earth science, now actually what we call as the earth system science most of the time, but sometimes it is also called as earth science, which encompasses all these aspects. So ocean science is also now we are forming as a part of the earth science. Now, why the oceans are very important, and especially last 2 decades, the ocean has been gained a lot of importance. And one of the reasons for this is that the most important is, of course, the life originated in ocean. And even today, it provides us food, energy, mineral resources, also the very storehouse of the biodiversity. And the most important is it controls weather and climate of the entire globe. So basically, it provides an ecosystem uh, for sustaining the life on the earth. So that is why it's very important for us to address these issues. Now, this has been recognized by UN, and they included as one of the sustainable goals, which is Sustainable Development Goal 14, which is called Life Under the Sea. And then how we conserve and preserve the ecosystem for the growth and expanding our economy. Now, the second thing which has happened is in this 2012, the UN Conference on Sustainable Development, they shifted from green economy to the blue economy. Now, what we realize is that as the climate change becomes more and more critical, we may have to be dependent on more and more of the ocean. And that is why the Professor Pauli coined this word as a blue economy. I'll explain a little bit blue economy later. But the important thing is now this UN, this current decade also has been designated as the decade of ocean science for sustainable development. So the idea is that we should provide the science related to ocean so that we are able to achieve this sustainable development goal 14 by 2003. So there is a lot of importance has been attached to both the ocean science and the ocean dependent economy. So what is now being viewed as a ocean as some kind of a national capital. So we should make use of in innovative way so that our livelihood or the life is improved. Now that is how we define the blue economy now as a ocean dependent economy, essentially to improve the quality of life, but at the same time, it should inclusive of a social development and along with the environmental and ecological security. So when we say blue economy, the sustainability part is inside itself. So we normally don't want to call a sustainable blue economy. When you say blue economy, it has to be a sustainable. Now, there are many aspects of the economy, and some of these I have listed here. Basically, is the marine bioresources and the coastal and marine ecosystems, also the mineral and the energy, tourism, the technology which we need for addressing some of the issues related to that, and of course, shipping industries and infrastructure. And since we are talking about economy, we also need to address which are the kind of hazards which we have on the ocean and how they are being addressed so that they does not affect the economy. And since we are saying that it should be development along with the conservation of the ecosystem, we should have a very robust coastal and marine management scheme. So this is the overall idea of a blue economy. I will speak most of the topic except on the ocean technology and shipping because of the time constraint, and I will stick my presentation to some of these aspects. Now, the most important is how do we utilize the marine bioresources, mainly related to fisheries. Now, in India, about 9 million people depend on the marine fisheries and allied activities like processing those data and all that. And there are about 700,000 fishers, so it's a very labor-intensive kind of a work. Now, the potential yield in the Indian EEZ is estimated to be about 5.31 million tons. Now, normally on an average, we catch about 3.8 million tons every year. It varies year to year between 3.2 to 4.1. It varies depending upon the various factors. The most of the fish catch, this fish stock is healthy, and most of them within the sustainable limits. Now, the system which we have in India is we provide a satellite-based advisories. That means we use satellite data which measures the ocean color, which gives us information about the chlorophyll, which is essentially converted into a productivity values. And the environmental condition, that means which is defined by the sea surface temperature, the current, and sea surface uh, waves. So this defines the condition. Now we know that the fish will likely to aggregate where the environmental conditions and the food both are available. So we try to find those kind of areas using satellite data, which we call as a oceanic fronts or the eddies, where the two different kinds of water mass meet together. Now, if you see, the traditional fishermen also try to look for this kind of a system where we try to see whether there is any foam or whether there are birds are flying to find out the potential zone. But what happens when you are looking from a ship, your vision is not that high. You hardly can see 3-4 kilometers to find out. But with satellite, we have a synoptic view, and that comes every day. So we are able to map these kind of an areas pretty well. And this advisories, which we build on this, have been used in India for last since 2000, and we have found that the success rate is very high, about more than 80%, and the search time is reduced to 30 to 70%, and increase in catch to 4 times. Now, many people can argue that since you are providing this kind of an advisories, there could be overfishing. Now, since last 25 years we have been doing, we have not found any abnormal rise in the catch. The catch remained more or less in the limits in which I said, limit within the sustainable limits as well. Also, each vessel which goes for fishing has certain capacity. Even if there are more fish available, they are not able to catch it. What we are trying is to direct them to the productive areas. So the less productive areas are conserved and they become productive over a period of time. So this has been pretty successful. And the also important, as I told you, the environment. Since the search time is reduced, our computation says that we reduce about 0.16 tons of a carbon dioxide putting into the atmosphere per ton of the fish catch. So you can compute that how much less carbon dioxide is now being placed into the system by using these advisories. And these advisories are given in the local language, and there are a variety of ways. All communication means are used in the fishing boats, the website, essentially pushing the information as well as we allow anybody to pull the information as well. So this itself has translated into tremendous amount of the economic benefit to the fishermen, and our computation says that about 17,000 rupees, that means roughly you can say about $2,000, $200 every trip which they make is more than what they used to make earlier. Also, if you put a carbon credit, there is a tremendous amount of benefit, and about 910 million tons of carbon we are not putting into the system. So this is a pretty good system which is being adopted, and which is one of the major issue of the making use of the knowledge for the benefit of the fishermen. Now, what happens because of the climate change? We have seen that there is a change into a fishing, the kind of species which we have, the sardine and mackerel, which are the prime major species which were caught on Kerala, Karnataka coast before 85. After 85, we have seen that this catch of sardine and mackerel has reduced on the Kerala coast, and it has increased on Goa, Maharashtra coast, as well as on the Tamil Nadu and Andhra coast. Now, this is essentially because of the warming of the sea, and the fish started moving towards a cooler and deeper areas than what it used to be. Now, this is very important information because many people now think the less catch on the Kerala coast of sardine and mackerel has been viewed as overfishing, but not necessarily it is true. It may be true in some cases, but by and large, this climate change is making a major issue. So, what we are now suggesting is that we need to also identify or measure, compute what is the fish stock likely to be available in each season, which we know that there is a relationship between the physical and biochemical reactions and the availability of a fish catch. So we are now trying to model that so that we can compute what is the sustainable yield every season, or like something like what we do for wheat and rice and many other crops, that before the it is harvested, we are able to give some production estimation. So we have been trying to do that so that we know that how much fish we should catching this particular year, depending upon what is the likely yield, depending upon the various conditions. So this is one more thing. The second thing which is could be harmful to the fisheries is the algal blooms, especially the harmful algal blooms, which could be of a dinoflagellates or a cyanobacteria. So we have now algal information services, which is again based on the satellite, which uses the information on the ocean color and sea surface temperature. And this is used to get the idea that where the likely algal blooms are there and where they are likely to move. So this information system is also available now, but we are trying to convert this into a early warning system so that we can provide the fishermen the advice that in the short term, what is next to 3-5 days, whether there is any algal blooms are likely to come or not, and that can be used to not to fish in those areas where the toxic algal blooms are happening. And this is also one of the major reason of warming as well as the excessive use of the fertilizer on the land, which transfers the nutrients to the sea. So this kind of information system is also in place. Now there are many others issues which potential. One is in India, there is a deep water fishery is practically not there. The potential is almost about 3.3 million tons as per our latest estimate. And these all kinds of fish between 200 to 2000 meters, which has been established both fish, finfish, and shellfish. So this is now to be utilized. The way how to be utilized is because you need a different processing, the catching, and different kinds of a technology which is required. There is another resource which has been found, a myctophids, which actually thrives in the low oxygen areas. And of course, it's a non-table fish, but we know that it can be very well used as a feed for a livestock, poultry, and aquaculture. So this is another major area which we need to harvest and utilize for the other than the non-table use. So other which we are trying is the cage culture, which is putting a cage of about 3 meter dia and about 9 meter in length into the sea itself, and then you provide certain seeds of a fish like cobia, and that also has been very successful. About 11 months, you get about 8 tons of fish. So this is the alternate way of providing income to the fisherman. The experiment of ornamental fishery in Lakshadweep Island, which was completely managed by women, is also very successful. And this also needs to be scaled up so that the income of the islanders also can go up. Also, of course, you know better than me, the lot of biomolecules and the development of new drugs, etc., is also possibility. And there is a lot of experiments are being done to use. Of course, there is many biomolecules have been found but to convert into a synthetic drug, as you know, it takes a little long time, and there are efforts are being made to make the drugs based on the bioactivity seen in some of the biota of sea. Now, all this fishery and this can survive and be if we have a very healthy coastal ecosystems. And the main ecosystems which are we considered today in the mangrove coral reefs and the sea grasses, and this the knowledge about their structure, function, and how whether they are vulnerable to the climate change or not, or the our human activities is very important. Now, the some of the estimate which has been made of the economic value of the ecosystem is about 33 US dollars per hectare per year. Uh, we are again now using, because the most of the services which are the provisional services like fisheries and all is well documented, but we also now to put the value of a carbon sequestration, which is very important. So that value is actually not included in these estimates. So we have been now conducting experiment in the Sundarbans to find out what exactly is the value of the coastal ecosystem, so that they are preserved and conserved. And once you have a good, healthy coastal ecosystem, your fisheries also will improve. Now, the mangrove, fortunately, in India, we map the mangroves every 2 years. And in last almost 40 years, the mangroves have increased from 4,000 square kilometer to 5,000 square kilometer. Normally, most of the time we see we are losing, but in this case, we are gained substantially. But that doesn't mean that everywhere it has been gained. There is a major gain in two most industrialized states, Gujarat and Maharashtra. The mangroves have increased, while in the other areas like Andhra, Orissa, and West Bengal, it has reduced. In Andaman, it has reduced mainly after the tsunami. So that is a completely different. But what this data suggests to us is the awareness is the most critical. If people are aware that this system are useful to us, they themselves see to it is they are preserved. And also there is a lot of plantation done in Gujarat and Maharashtra, the new plantation, so that the protection from the erosion, also the carbon sequestration and all that is quite useful. The other major ecosystem is the coral reefs. And this, of course, all of you may be reading quite a bit about the bleaching, that the increase in the temperature and the corals are bleached. Now, that, of course, is true. There is no doubt about it that coral do bleach. But our observation says that the acropora, which is the soft corals, they are first to succumb to the increase in the temperature compared to the hard coral like porites. But at the same time, we have also seen that the soft corals adapt to the higher temperature faster. So in the Gulf of Mannar, we are seeing the new recruits in those areas where the corals were bleached once in 1998, and afterwards we are seeing the new recruits are coming up. So corals are also trying to adapt to the higher temperature. So I'm not much worried about increase in the temperature and its effects on the coral reefs. And we have seen that like in Persian Gulf, in Gulf of Kutch, the corals surviving in much higher temperatures. And if you see these corals, it survived 450 million years. All these where they have undergone a variety of changes in the environment. Of course, the species have changed, but the corals as such has survived. But the more important thing is the increase in the pH, the acidification of the ocean, which is also happening. And one of the forecast which we have in India that by 2100 it will increase zero point 0.3 to zero point 0.4 pH of the ocean water. Now this could be a very dangerous because that will dissolve the calcium carbonate and the not only the corals but many other biota will get affected. And since the temperature is increasing, the acidification and it will also lead to a low oxygen. I think that is what combination of this all three is going to affect the corals much more than only temperature, which many has been advocating. So what we need is that this carbonate system as a whole, we need our understanding about the carbonate system and how best we can predict the pH at different IPCC scenarios. I think that is going to be more critical for us to understand what is likely to happen to the corals in coming years. Now, currently what we have is the coral alert, bleaching alert system. So we have been able to provide where the bleaching is likely to take place. We cannot do any action, but we are just trying to understand that how best we can predict this so that ultimately when we want to build a model for what is likely to have a coral, I mean, what likely to happen to corals, we would able to know. And this is important because the economic value as computed in Indonesia is almost $3 million per hectare. So it's a huge value. And this value, for us to get the benefit, economic benefit, we need to conserve and preserve the coral reefs. Now, as you know that the marine biodiversity is also equally important. And this is for us to understand that how anthropogenic activity and the impact of global warming can change the biodiversity. We have a program called Census of Marine Life. It is a part of the international system, and the information is kept into International Ocean Biogeographical Information System. Now, what is done in this is, you can see some of the dots. These are the areas where the 3 degree by 3 degree grid, the information about the biota, right from microbes to wells, from surface to this seabed, is collected and documented. And any new species, etc., also been reported. Some of the new species you can see here also is put. So this is the one kind of a system which is being built, and we do like a population census every 10 years. We suggest that we need to have this kind of a census also every 10 years or every 20 years, so that we know if there are any changes happen, or and then we would be able to understand what exactly is happening in this. Of course, there are some areas you can see that we have a large amount of information, but you see most of the area we don't have the information. So this is cannot be done by any single country. You need all countries' support to provide the information and collect and provide the information to get this idea. So this, of course, is going on, but it's a long-term process. But I'm sure that we would be able to understand that how biodiversity is going to be affected because of the climate change. Now, another major earning is from the tourism. Now, many think that the tourism is also, in a way, can harmful to the environment. So there is a European concept, is the blue flag beaches, which is Foundation for Environmental Education, which is in Copenhagen. Now they have a system by which you identify beaches which are safe for people to swim, and you include along with this the environmental education of this end. So this activity also has been started in India, and some 13 beaches have been identified as the blue flag beaches. And we have seen that these beaches are now preferred by people, and lot of people come because apart from safe, there is certain facility also provided for change rooms and the shower and washrooms and all those, and also the lifeguards and all other things. And this, the small portion, minimum about 500 meter to be identified for this purpose, and the rest of the beach, because many beach in India are used by fishermen. So this concept is now being propagated, and we would like about 100 beaches to be designated as the blue flag beaches so that people can use it, and along with that, the environmental education also is provided. Now, the next is the ocean minerals and the energy. We know that there is a lot of placer minerals, especially on the Indian coast of Kerala, Tamil Nadu, Andhra, Orissa, and Maharashtra. Mainly, this is ilmenite, rutile, garnet, zircon, skyanite, magnite, monazite, and all this kind of. The ilmenite reserves are very huge, about 22% of the world reserves. Now, this is because of various reasons they are not being mined as of now. But now there is a 5 minutes by 5 blocks have been identified, and hopefully the mining will start in a manner in which it doesn't affect the environment. Of course, when you mine, there would be some damage, but we have to see that how we can minimize the damage. And after the mining is over, what steps we need to take to bring back the environment. The total value is huge, is about 150 billion as of now, and this is the another area which is likely to, in the short term, will benefit. The second is the very long term, and this also many people are not very convinced that why we should go for the deep sea minerals. Now, what we are getting, there are three different kinds. One is a polymetallic nodules, which is in manganese, copper, nickel, cobalt. Then there is the polymetallic nodules, which is mainly copper, platinum group of minerals, zinc, gold, etc. And third is the cobalt-rich ferromanganese crust. Now, in this, the polymetallic nodules and the ferromanganese crust are very critical because of the need of a nickel and cobalt and manganese for lithium-ion batteries. And world over, people are trying to build a other source because today most of this comes from the China, and it's a single supplier. By 90% is coming from there, and this is, of course, currently we know, like in polymetallic nodules, we know that the huge resource is available, and the total value is actually 380 million tons, and the total value may be around 187 billion. Of course, these are changing depending upon the supply of this material. So, but this may be a possible in another 15, 20 years. There are several issues, but the current focus is to find out where such resources are there and what kind of a technology will be needed to mine them and to refine them for this. Because the metal content could be very small, like cobalt is hardly 0.3 to 0.9%. So it's a low, but it's a very rich source of cobalt. So this is another area which is likely to come up in near future. Also, the many areas now been getting the fresh water from the sea. Now, most of the time, these fresh water is being taken from the reverse osmosis method, which is very popular, and but it also the waste from the RO is a highly saline, almost the 30-40%, and that kills the marine life in that. So in India, we have devised another method which is called low temperature thermal desalination, which is essentially mimicking a monsoon. The seawater, the surface seawater is brought to a chamber, and where in a vacuum chamber, so it starts boiling, and the vapor is collected into the another chamber, and the cool water from the depth of the sea, about 800 meters, is brought to cool, so you get a fresh water. Now, the only condition necessary here that you need a deep water very close to the your. So this is working pretty well in the Lakshadweep Island. We have a plants for running for last 20 years, which can produce about 100 to 150,000 liters per day, which is quite sufficient for the drinking water needs of the islanders, which are the population varies between 5 to 10,000. So this is quite sufficient for them for drinking water. Now, what we have been proposing that similar plants can also be done in thermal power stations, coastal thermal power stations, because we already have a warm water which can be used to evaporate, and you can get the surface water to cool it down. So this is the other, and we think in the coming years when you have more uh, activities at the deep sea, you will need large amount of water. So we may need an offshore plant as well to produce the fresh water. And this project report has been prepared, and we are now trying to find out the funding so that this kind of plant also can be demonstrated. The energy, of course, we know oil and gas is coming now almost from the ocean. So I'm not going to talk about it. But there is another major, what we call as the gas hydrates, is a solidified methane at the depth of more than 2,500 meters. Because of the pressure, the methane gas becomes a solid and it becomes an ice-like crystalline form, which we call as a gas hydrate. Now, this is a very huge resource of the gas hydrate. There is a lot of work is being done on the gas hydrate. The only problem today is that we need a technology to utilize this resource, because you have to bring this resource to the surface without losing the methane. Otherwise, it will escape to the atmosphere and add to the more water. So this is the another area which is likely to come up in near future. The other is India has a very huge target of 37 gigawatts of offshore wind farms, and this will need a very huge infrastructure. And I think, though we know that there are areas where there is a sufficient wind for the round the year, but alone having a wind is not a sufficient condition to put the offshore wind farm. What we need is what kind of a substrate it is, which can sustain the weight of those heavy wind farms and the port infrastructure, which will need it to service this wind farm. Now the next is some of the hazards. We know that the coastal areas have cyclone, floods, the marine heat waves, the tsunami, and many other things. But the most important thing is we need to identify which are the vulnerable areas so that those areas can be avoided and the investment made in the other which are more safe than those areas. Or even if you have to do it in vulnerable areas, you would know that how much additional investment you will have to make it so that your structures or whatever infrastructure you build is safe. So we have this kind of a maps which is looks at the what is the likelihood of a change which can occur because of the different hazards. Could be cyclone or a tsunami or a flood, and what is the possibility of this system to address to this changed environment condition. So based on that, we have divided the entire Indian coast into these different. So we know that which are the areas you can see These red are, which is very vulnerable, but this yellow and this orange is next, and the third is the yellow. So all areas will be vulnerable, but this region may be relatively much safer than putting your investment in this region. So like that, this kind of studies have been done. We have a very good system for cyclone predictions. You all probably aware of it. Last 15 years, we have reduced the lives lost from 10,000 in 99 to now, if you see, there is hardly any life lost. The last cyclone in Gujarat, there was not a single death. So not only the prediction system, but the response system to this prediction is also in the place. And people are conscious and they have a trust in the forecast and the government action, so that we have been substantially able to reduce the loss of life. So I think this is a very good system, and this information is provided not only to the India alone, but all countries in the Bay of Bengal and the Arabian Sea without any cost to them. So this is a information which is being provided to all countries, and the India hosts the regional specialized meteorological center of a WMO. Similarly, tsunami, of course, many people argue that it comes once in a while. So why you need to invest so much into this? So it is also important to tell that tsunami is not going to come. So we have now a system where we are able to provide the information about the travel time, at which height it will come, and what is likely inundation within about 10 minutes to all countries into the Indian Ocean. And this information is now operational since last 15 years. And till today, we have not given any false warning. Similarly, we have a system for the flood, and I won't go into the details of the flood warning, but the ultimate output of the uh, system is shown in a 3D, and you can see that the areas which are likely to be flooded are shown in the color. The red is likely to be flooded maximum, then orange, and then yellow, and the green will not be flooded. So this kind of information is very useful to the corporation, the local authorities, so that they can take appropriate action. So this system is for Chennai, and Bombay is already in place, and we are trying to build similar for other urban settlements also. We also provide routinely information about the currents, waves, and the sea surface temperature, which is very useful for all shipping activity, fishing, oil and gas production, tourism, defense, all kinds of things. So these are routinely provided 3 to 6 hourly forecast at every 5 days, before 5 days in advance. And this is for tides also, the information is provided. Apart from India, we also provide this service to Sri Lanka, Maldives, Seychelles, Mozambique, Madagascar, and Comoros. So these are the information which is required for successful economic activities. Now, the last is the marine area management. In India, we have what we call as a coastal regulation zone. That means from a high tide line up to 500 meters, the certain activities are prohibited or restricted. And we have the coastal zone management plans for the entire Indian coast, that what kind of activities are permitted in which kind of a zone. So all this information is available, and this is being used to regulate the activities, developmental activities in the coastal zone. Now, what we need in the future is that most of the thing which I showed you is a short term or a medium term kind of a forecast. But what we need is a seasonal and decadal scale forecast for variety of the things like how the sea level is going to change, what is cyclone intensity and frequency going to change, the how the biochemistry, the pH value going to change and it impact on the ecosystem and how it will change the fishery and ultimately the ocean health. So this kind of information we would need for successful economic activities. So the work which we need to do now is one is we need information about the ecosystem. And if wherever there is an issue, we need to restore the ecosystem. Second, we need very effective coastal and marine spatial planning. Third, we need to build sustainability indicators which are useful uh, for understanding that our activities are not affecting the sustainability. The fourth, we need to have a framework where we can bring the social, environmental, and economic data together so that we have a good accounting system. The fifth, we need a integrate all the scientific data to have a digital ocean so that we can also ensure the ocean health. The capacity building at the institutional, individual, and regional levels. And since there are different kinds of sectors involved, right from fishery, shipping, tourism, mining, and many others, so we need the institutional framework and the governance structure for how do we uh, secure the financial resource based on the knowledge which we generate on those. So I think if we have a responsible stewardship of the ocean, I think that investment will pay dividends for the generations to come. So thank you very much for this opportunity for to address this issue and sharing my views on this. Thank you very much.
Hello. Dr. Archana?
Yes, sir. Thank you so much, sir. Singh, sir, please continue.
If you allow, it's a fantastic talk. Dr. Nayak,
Yeah,
was a fantastic information. We had many questions, but
sure.
I find that in your talk, you have answered many of them very nicely.
Sure, sure.
But I just wonder, when you talk about sea temperature,
Yeah,
the depth of ocean, the temperature should be same everywhere, or would it be different?
it will be different at different places. It won't be. See, when we say that the average temperature is increased by 1 degree or 0.7 degree, it is the combination of all this. The temperature is controlled by many factors. Uh, One is, of course, the energy of sun which you receive. So the tropical areas, receive much more energy, and they are warmer, and the warmer water will try to go towards the poles, which are the cooler ones. That's how the currents develop. But apart from that, the the changes into the seabed topography, is there any other issue? So there are many other factors which control the sea surface temperature. So it is never same across the entire ocean. It would be quite different. Like if you go to Persian Gulf, it would be much warmer, though it is in much northern side than say Bay of Bengal. Uh, the also depends on the fresh water. Like Bay of Bengal receives lot of fresh water compared to the Arabian Sea. So the fresh water absorbs more marine heat than the saline water. So Bay of Bengal will be warmer than the Arabian Sea. And that is why you get more cyclone in Bay of Bengal compared to Arabian Sea. The marine heat waves also comes into Bay of Bengal more than. So there are many factors. I mean, it's
Very exciting. One very naive question. How does the quality of fish vary from fishes from the ocean and from lakes?
Yeah, that depends on, because lakes is by and large a freshwater fish. So they have a different taste and the structure compared to the marine fish.
They have
So that
less
is
salt.
the, yeah,
Salt tend to be
because
different.
of the, that would be different. Even the varieties in the sea would be much more than what you get into the freshwater.
Okay. Any other member who has a question?
I have one question. Congratulations, Dr. Naher, for the excellent presentation. I don't have one question specific. I have a reflection about the exploration of the ocean for the next decade for different countries. 17% of our planet is ocean. We have many interests to develop exploration, the petroleum, the mineral, the food resource, the additives for the supplements, like omega-3 from the catch fish from the flower of fish. That will, in the future, will give him more interest for each country, for all these ocean resources. What do you think about the impact, environmental impact of this increase of the exploration of these resources? What is your opinion?
Yeah, I mean, anything which you do definitely would have some impact on the environment. I'm not saying that whatever our activities which we have been doing, there is no environmental impact. But what we can do is we can use our knowledge so that the impact is minimized as much as possible. That is what our knowledge we use to minimize the impact. Now, there is one thing which is I mentioned about the fishery advisory services. The another major environmental impact which has happened is earlier when they were not knowing where they will get the fish, they normally used to do the bottom trawling, where all the biota will be caught. Now, that since they know that in this region there are pelagic fishery, they are using more a gill netting techniques to catch the fish than the bottom trawling. So, with the improved understanding and the information to the fisher, they are using more environmental friendly techniques to catch the fish. Now, same thing can happen when you mine the minerals and all. Now, as you know that there is a very strict regulation about the environmental impact assessment statement, especially in the deep sea. As of now, the International Seabed Authority has not allowed anybody to mine the deep sea minerals. They would want to make sure that what environmental precautions would be necessary and how do we ensure that this mining is environmental friendly. So I think before the mining start, I think the International Seabed Authority will make sure that the damage is done is minimum. Now, if there is any particular damage occurs because of our activity, we should also have to have a plan or a strategy to how do we restore that back. So I think all these things has to be put together. Then only I think we can minimize the damage to the environment. But in principle, whatever you may do, there would be a damage. But in what I would say, the way to minimize while the activity is on and to restore back to the system after your activities over. I mean, that should be the overall strategy.
Thank you. Thank you very much.
Good afternoon, Dr. Nayak. Am I audible?
Yes,
Yeah,
yes, yes.
Yeah, this is Dr. Krishnani, sir, Joint Director Academics from IIB Ranchi. Sir,
Yeah.
I have a couple of queries. Dr. Nayak, it was a very informative talk. Thank you very much. Yeah. Dr. Nayak, actually, this uh, Capophycus cultivation and carrageenan extraction in other Asian countries like in Philippines, it's going on very well. But in India, I think it's not gaining that much momentum. So, what is the reason actually the Capophycus cultivation and the seaweed, which is very much required in our country as well? But I think in our country, we are not doing that much Capophycus cultivation and carrageenan extraction. And my second query is the microplastic. Microplastic has created a lot of problem in mariculture and also in coastal aquaculture. So how to deal with that situation? It has become a big problem nowadays. Yeah, thank you.
Yeah, I think that somehow that culture has not taken place much in India. I think the reason is uh, basically I think they are not sure of the market. So that may be the one reason. Actually, under the Deep Ocean Vision, we are now promoting this, that trying to support some of the universities and some of the startups to take up this idea and address this issue. Microplastic, I agree. There is an issue. Only thing which I'm not able to understand is what we need. That the most of the studies says there are microplastics in the fish or X or Y or Z. You know, that information is available. But I think what we need also is that what is the minimum or maximum levels which would require for us to understand how it affects the biota. There are some studies that it affects their physiology, their reproduction, and all that. But very detailed analysis is not available. That is number one. Number two is the issue of microplastic is similar to climate change in a sense that once the plastic goes to it is going to remain for 70 to 100 years. It doesn't degrade that easily. Even those we say biodegradable, actually it degrades into very minute particles only. It doesn't completely degrade. Or you know better than me about that. So there are some people say there are bacteria and all that which can consume then all that. But I don't think this problem is going to be resolved very soon because the ultimately it is I think the how do we manage the plastic waste. I think we need to address that issue much more, that if we can address that the waste and nothing goes to the ocean, then this problem can be resolved. But once it has gone to the ocean, I'm not very sure that you can resolve that problem. What you can do, you can only say that I found this much microplastic here or there, but that is not going to solve the problem. So I think the effort should be the managing the plastic waste, in my opinion.
Thank you, sir. So just one more query, if you kindly permit me.
Yeah, sure.
Sir, this do you find the potential of inland line aquaculture in Haryana, Punjab, and Gujarat? Because now the culture-based like this aquaculture and culture-based fisheries. Now in Haryana and Punjab, which are the salt-affected area, at present we have about 10 million hectare area which are affected with the salt. Now where we can do the water salinity is about 10 to 15 ppt, and they are doing this like chanos and Magilcephalus, and also they are doing the shrimp farming in those areas because they are the salt affected area. So they are the inland line aquaculture and they don't have any coastal area over there. But inland line aquaculture they are doing, but the only problem they are facing is the effluent treatment. Where to discard that effluent? So yeah.
Yeah, I agree. Actually, I believe that the aquaculture should be done only where the substrate is of a clay or a mud. In Punjab and Haryana, it is not so, it's more sandy. So it will percolate much below. So ideally, it should be done where the mudflats are there on the coast, where the percolation is minimum. And the most ideal areas is where you have a salt pans, because the water does not percolate below, so that it evaporates and you get a salt. Those kind of areas are ideally suited for the aquaculture, and the intensive techniques should not be done. Semi-intensive is okay. And because once you choose a proper substrate, and then the, as you rightly said, the discharge also can be done into the sea. But Punjab and Haryana, I'm not very sure that though you have the salt affected areas, may not be a good area to do this, because it will further increase the problem of a salinity into the groundwater. Is already a serious issue, further aggravate.
Thank you, sir. Thank you.
Okay, any other question? Comment?
From my side, in fact, thank you. It was highly comprehensive lecture that Dr. Nayak, in fact, delivered. I told you that I was very just following him since last 2014 or 10 onwards, when he was the secretary of the Ministry of Earth Sciences. And his lecture was not only for the research purposes, it was excellent and wonderful, where there is a lot of possibilities. That is narrated, in fact, but it has a lot of academic interest also. I believe that he will be a wonderful person in BRSI, because he has already delivered such a wonderful talk in BRSI, and we have the several, in fact, the great scientists from different countries in IBA and the BRSI, and it will be a great opportunity. And
he should become part of BRSI. That's what you want to say?
Yeah, in fact, he will be there.
From this year, he should become. He will.
Yeah, that I'm saying, and there is a lot of possibilities, in fact, because we have a lot of several countries researchers are with us, and he will certainly a wonderful person for us. And nice. I think that Ashok will, in fact, he will try his best and he will coordinate with those. And overall, I can say that I told you that since last more than 10 years, in fact, just I was looking his work and all these things. Whatever he narrated is wonderful, that I can tell you. For a country perspective also, and international also. I will not go in details. Thank you very much.
Any other question or comments? I saw many comments from the audience. They all were very excellent, appreciating the talk, information, and a lot of knowledge in this talk. Very fantastic. There's no doubt. We are very delighted to hear such a wonderful talk. And the BRSI will be very happy, very grateful to become part of the BRSI. So that's what I would say.
Thank you. Thank you very much for all the comments and the.
John has to come in. But there's a question. Please.
Yeah, I saw some hand raised by someone. Yeah. So thank you very much for this excellent opportunity, and we had excellent interaction, and very happy to be answer any other questions or anything, not now, but any other. You have my email, so you can send me an email, and I will be.
You are part of IISc now anyway. You know how to contact you. You know you are there?
Yes, sir. Yes, sir. Yeah.
What is the next course?
Yeah, so now the vote of thanks. So I thank Professor Nayak for this wonderful lecture. So all the families of BRSA and IBA might have benefited very much because of you give a very comprehensive and very vast information about the blue economy. Thank you, sir. Thank you very much. And I also thank Professor T.P. Singh for all the support and all the things sir is doing for the BRSI. And I thank Professor Jose Texera, Professor Sokol, Professor Christian LaRoche, and all other members of IBA and BRSI for making the activities of the society is wonderful. And also thank Professor Archana for coordinating this BRSI Global Lecture Series, and I thank all the participants in this Global Lecture Series for taking your time and participating in this one. So thank you very much, and then
Thank
we
you.
will
Thank you very
meet
much.
in the next
Thank you very much.
lecture series.
Thank you.
Thank you,
Bye
sir.
bye.
Thank
Bye.
you. Thank you so much.
Thank you,
Bye.
Dr. Naik. Thank you very, very much.
Thank
you.
you.
Thank you very much. Thank you.
Thank you.
Thank you.
Okay, Binod, thank you so much for organizing.
Okay, thank you, sir. Thank you very much. See you. Bye.
Thank you.